So hey guys, what's happening? My name is HashirVani and welcome back to my channel. I'm back here with another masterclass in our Revit MEP modeling. So today's masterclass is going to be about firefighting systems and fire protection systems and how they are modeled in Revit. Before we start modeling, let us first of all understand what these systems are and how they are used. So firefighting and fire protection systems are networks and equipments that are designed to detect, control and suppress fire inside a building. So it helps to, for example, there is a fire inside a building, so it detects a fire, it controls that fire and it tries to suppress that fires by using water and different systems that we have that we're going to be learning in this masterclass, right? So fire protection system includes everything that helps prevent a fire from spreading, from sprinkler systems to pumps to pipings to valves to alarms and to safety devices, right? So these systems are one of the most essential parts of MEP design because they ensure the building remains safe and compliant with the fire safety standards that we have, right, according to the region that we live in, right? So with that, let us understand the basics that we have in our fire protection systems. Can you see here we have a typical layout of a fire protection systems here, right? So let us understand what are the different systems and how they interact with each other, how they work with each other, and how they help detecting, how they help controlling and dispersing a fire, right? So let's start. So guys, let's start with this layout and understand what each of the equipment is and what each of the equipment does, right? So let's start with this water tank. So this water tank is a static reservoir, so it's used as a static reservoir that stores the water, and this water is then used for firefighting system. So this is sort of a reservoir. So this is used when the fire system gets activated and it detects a fire and the fire sprinkler systems get activated. The water is taken from this water in accordance with the water that has been provided by the fire hydrants or the main pipes that are connected to the fire hydrants. In accordance with that water, so both these waters get used simultaneously and then they get pushed through these pipes and eventually into the fire sprinkler systems, right? So this water tank, it basically acts as a reservoir. Now the next thing that we have is our pumps. Can you see we have a pump sets here? If I zoom in here, you can clearly see that we have three sort of pumps here. So we have pump number 1, we have pump number 2, and then we have a separate pump here called a jockey pump. So these pumps are maybe diesel pumps, they may be electric pumps, and then we have a separate pump called a jockey pump. So what is the jockey pump and what are the main pumps? So this jockey pump, in our fire sprinkler systems, we have to maintain certain pressure and certain flow through these pipes in order to account for all the leakages we may have. So why do we have to provide this particular pressure into these pumps, into these pipes? Because whenever a fire is detected, we may not have that much time for the water to get sort of pumped from here, and then the water may reach here, and then the water may go into the sprinkler systems, and that might take a little bit of time. So what we do is we have this fire system on ready. How do we have that ready? We already have a pressurized pipe systems here. So the water has already been pressurized and is already present at the tips of the sprinkler system. So how is that pressure maintained? So that pressure is maintained by this pump called as a jockey pump. Then now, what are these main pumps for then? When these water sprinkler systems get activated because of a fire, so at that particular system, a small pressure or a small flow may not be enough to get the water flowing in all these sprinkler heads at a particular pressure. So for that particular pressure to be maintained during a fire incident, we have to use big pumps that have a large flow rate, that have a large pressure sort of capacity. We use pumps here. We use two pumps in accordance with each other. For one is used as a sort of a backup if the other doesn't work. So these pumps provide the flow and the pressure rate that is necessary during a fire incident. So these pumps are called as main pumps, and this pump is now called as jockey pumps. And now the next thing that we have is our suction manifold. So this suction manifolds draws the water from our sprinkler, from our fire hydrants or the main pipes that is connected to the fire system, which is not in accordance with this water tank, right? So we may have a second system that gets combined, and then this water gets pushed into the system right here, right? So the next thing that we have is our discharge manifold. So all these pipes, they get connected using this pipe called a discharge manifold. This is a pipe which combines all the inflows. We may have an inflow from this water tank, and then the second inflow may be from a fire hydrant, and the third inflow may be from a mains pipe that is used that is provided by the municipality, etc., etc. So all these pipes get sort of combined into this discharge manifold. And the next thing that we have is our wet alarm system and flow meter. We'll take a look at them a little bit later. And then the next thing that we have is a vertical pipe. So this vertical pipe is known as a riser pipe. So it connects different levels in our buildings. We may have a first floor, second floor, third floor, fourth floor. So all these floors, the systems in these floors is connected by a vertical pipe known as a riser pipe. And then we have a pipe. Can you see we have a sort of a horizontal pipe. It is known as, so these pipes are called as branch pipes or cross mains, right? So this pipe here and this pipe here, these are called as cross mains. And the let us take a different color here. So these pipes, this pipe is called as a riser pipe. And then we also have these sort of pipes. Let's use a different color. Let's use green for this. These small pipes that feed the individual sprinklers, can you see these pipes? These pipes are called as laterals. We call them a lateral, and they connect the sort of cross mains to the sprinkler heads here. So we may have a system of laterals, and then these lateral in turn gets connection from this cross mains, and the cross main gets connection from the check valve, the risers here, and the risers may get connection from the discharge manifold, and the discharge manifold gets connection from the pump systems, and these pump systems gather water from the water tank and the fire hydrants and the pipes that are provided by the municipalities, etc., etc. Can we see we have some other equipments here called a check valve? So what is this check valve? So the check valve is a non-return valve. So what is it? It's a non-return valve that prevents the backflow of the water from these sprinklers back to the pump system that we have here. So it is a non-return valve that allows the water to flow only towards the sprinkler and prevents the backflow from the distribution of the pipes towards the pumps or the tank. So it prevents water loss and the cross flow between the different pumps, right? So it is sort of a one-way door for the water to get pushed in this particular direction and not in a return direction. The other thing that we have is ZCV. Can we see here we have an equipment here as well, and then here as well, called as zone control valve. So what is this zone control valve? A zone control valve is a valve that isolates a particular area or a zone of the sprinkler network. So it isolates this sort of system from this sort of system. And how is the separation done? It is the separation is done using a valve. So it is essentially a valve. So each zone valve is electrically supervised, so it may have a tamper switch so that the fire alarm system knows which valve is active and which valve is not active, right? The next thing that we have is can you see here on these laterals we have a system of sprinkler heads. Can you see we have a sprinkler head here, we have a sprinkler head here, and the dots here are sort of showing these sprinkler heads, right? So let us take a closer look at this sprinkler head. So this is the sprinkler head components. If I zoom out a little bit and move it a little bit up, so this is the sprinkler head, is the typical layout of a sprinkler head. So it has a deflector, it has a cap, it has a thermal linkage, and it has a frame. So how do they work in accordance with each other? A typical sprinkler consists of a frame, thermally operated linkage, a cap, and an orifice. We have a sort of a hole here for the water to flow, and then we may have a deflector here as well. So what are the functions of these typical elements? So let us go to the how the fire sprinkler system actually works. So here we have a typical sprinkler head consists of a plug head held in a place by a trigger mechanism. So what is this trigger mechanism? The most common type of trigger is a glass bulb filled with a liquid that expands when heated. So in this we have a glass bulb here. In the glass bulb we have a liquid that is activated thermally. So less common, we have two types of systems here. We have a glass bulb system, and we also have a metal plate system. So we essentially have two plates of metals, and in between these two plates of metal we may have a solder or a solder, right? And this solder, when some fire incident happens, this solder gets melted and the connection between these two metal plates get broken, and this triggers the fire, this sprinkler head to release all the water at once, right? Similar thing happens here. If when the sort of the glass ampoule breaks, it triggers the sprinkler head to release the all the water at once. And now this all water, where does it go? It gets it sort of gets thrown at this particular deflector, and then deflector sort of acts as a spread. It spreads all the water evenly in all the directions on the fire, and the fire gets controlled, right? So how does the sprinkler system work? This water bubble is sort of a ampoule gets breaked. However, at what temperature it gets break? The most common temperature that we have is our 155 degree Fahrenheit. It's in Fahrenheit, right? And then it gets breaked, and all the water gets sort of falls on this deflector, and then the deflector sort of disperses all the water. And what types of different type, we have different types of sprinkler head here. We have upright. If it's an upright position, for example, we have this is a lateral, and then the sprinkler system is sort of present here. I'll just zoom in a little bit, or I'll just make it here. So I'll just show you guys. So this is a lateral here, and the lateral we have a sprinkler system that goes up. This is the sprinkler system here. If it goes up, it is an upright. If it is in the downwards orientation, then it is a pendant. And if it's on the side wall here, it is known as a side wall system. So each system has its own advantages and disadvantages, so we'll talk about that later. Now if we move down how a sprinkler system works, I'll show you guys a video how this actually works. So we have a YouTube video here. Can you see? We have a sprinkler head, and then we have a glass ampoule. The temperature is rising, and the glass ampoule gets broken, and the water gets forced on towards the deflector, and then the water gets spread everywhere, right? So this is how a sprinkler system actually works. Now let's go back. And then we have different types of sprinkler systems. We may have a wet system, we may have a dry system, we may have a deluge system, we may have pre-action, we have water mist. In a wet pipe system, uses automatic sprinklers attached to a piping system filled with water and is connected with a water supply, so that the water discharges immediately from the sprinklers opened by the heat from a fire. So it's basically the system that we studied earlier. So we have a water, the water flows through these sprinkler pipes, and then when the fire is detected, this sprinkler system, the sprinkler head breaks, and the water is dispersed through the sprinkler heads and deflected towards the fire, right? So it's the most common type of system. It is used for buildings where there is no risk of freezing. So it's used in countries that don't have that much freezing climate, so that all the water may get frozen, and the sprinkler system may be deemed a failure there. So in wet pipe system required multi-story or high-rise buildings, and for safety such as those installed, okay, this is installed in shopping centers, high-rise maybe, and high-rise buildings and multi-story buildings, all this types of buildings uses. So guys, now let's take a look at the design drawings that we get from our design engineer. We have some site information here, and then we have some sections here. We'll move on to the next page quickly. We'll move on to the next page. Can you see here we have some information. We have some notes here, we have some flow calculations, fire protection summary, etc, etc. So you guys have to go through all of them. And now comes the main plan. Can you see here we have some highlighted section here. This highlighted section gives us the information about the point of connection. It is the point of connection where the fire protection system gets connection, gets the actual connection from the main hose or the water hydrant pumps, etc, etc. So we have some information here. Can you see we have a section here, that section is shown here. Can you see we have a pipe, point of connection is here, and then we have some riser here, we have some fire protection equipment here. You can get more detail about the equipment here. It is a Colt series C300, so all the details, features, specifications, etc, etc, the dimensions, weights, etc are given here. If we move on to the next page, you see so this is all our underground piping plan for our fire protection systems. We move on to the next page. We have the level 1 plan. This will be modeled in the ceiling space of the below the level, the slab of the level 1. For example, I'll just give you an example here. If this is the level 1 ceiling. This is the ground, this is the ground here, and this is the slab. I'll just make it a slab. Can you see we have a slab? This is a slab, and then we have some, let us say, some underground. This is all soil. Can you see we have soil? So all these equipments here mentioned in this building will be modeled here in this space. Can you see we have a space here, so it will be modeled in this particular space. We have to model this below the level 1 slab, right? So I'll just control Z for now, and then let us take a look at this particular design drawing. So we have a point of connection in the underground, and then we have a riser. That riser gets connected to this main pipe here. Can you see we have a main pipe, and then we have some laterals, and we have some sprinklers. Can you see we have the CPVC pipe? It is the piping legends are given here. We have steel pipe, it is a single line pipe, and then we have dash pipe, denotes the CPVC pipe. And then this is the level 1. We have some section views here. For example, here near the point of connection from the underground, we can zoom in and we can see that particular equipment that we took a look at a little while back, and then this goes up, and then we have a left bend, then it goes a little bit down, and then this way, and then we have some equipment here. So you guys have to go through all of them, understand it, understand the sections, where the sections are placed, and then correlate those sections with the section elevation, and try to figure out how these pipes are actually how they actually have to be modeled here. And then we'll go to the next page. We have some ceiling plan. Can you see we have a reflected ceiling plan here? So did I show you guys the sprinkler legends? Here we have the sprinkler legends. So if we have this sort of a symbol in our design drawing, it means a concealed it means a concealed sprinkler. So the sprinkler has to be concealed inside a ceiling. And if we have this sort of a circle here, it means an upright, so it means the sprinkler is pointing upwards. We have some other types of concealed, maybe the temperature differences there, and the finish differences here. And then we have sort of this crossed, it is a pendant, so it is pointing downwards. You can see them here. Here we have some pendant, we have some upright here, and then maybe we'll have the different ones here. Yeah, we have this one here, and then we have another type here. And then this sort of room is labeled here. We may have an enlarged plan for this room in the later sheets. I'll just move to the next sheet. We have the standpipe diagram here. Can you see how the standpipe diagram works? We'll see how the we may have a section for this, right? In the isometric view, if I move to the next page, do we have some isometric views? Yeah, we have an isometric view. So this is the point of connection. The pipe goes like this, and then we have this equipment. We have just seen this equipment, and then sort of we have a stub up and riser here, and then in this particular riser we have a sort of a main pipe that gets connected, and then we have some branches here, and then this standpipe. Can you see we have some equipments in this standpipe here, and we have our other on the other side of the building, and this standpipe is shown here. Can you see we have a standpipe diagram of this, we have a section diagram of that particular standpipe. I'll show you guys how to read these standpipe diagrams, and then we move on to the next page. We have some sections, and move on to the next page. We have the isometric view here of the standpipe. We have some enlarged plans for a particular system of rooms. Can you see here we have some sprinklers here. We have the length of this pipe, this particular section of the pipe, and we have the dimension of this particular pipe. And then do we have some legends here? We have for the legend we may have to refer to the main plan. We have some other enlarged plans here. So now I'll tell you how this sprinkler system here works. So every sprinkler will have a range, so we may not be able to move this sprinkler system beyond the length that are prescribed here. So how do we read this particular sprinkler system? So we'll go here. Can you see we have a sort of a main pipe here, and then we have some laterals here. Can you see we have laterals here, and then the laterals each sort of a the distance from the main pipe to to a sprinkler, and then from that particular sprinkler to the different sprinkler to that particular sprinkler to different sprinkler is mentioned here. It is mentioned on the right hand side of the pipe. Can you see we have a 6 feet 10.5 inches? So this means that from this center of this main pipe to the center of the sprinkler, the distance of this sort of lateral pipe connecting a main pipe to this sprinkler should be 6 feet and 8.5 inches, and then from this this sort of a sprinkler to this sort of joint here should be 2 feet 9 inches, and then from this joint to this sprinkler should be 8 feet 10.5 inches, and then from this sprinkler to this sprinkler here should be 11 feet 7.5 inches, and then the pipe dimensions here, can you see we have 1 and 1.25, right? So 1.25 feet. So 2 inches, this is in inches guys, so it is 1.1 and 1.4 I'm sorry guys, it is 1 by 4 1 by 4 inches, and then we have 1 by 4 inches here as well, and then we have 1 by 4 inches there as well, here as well. And so this particular denotes the dimension, and this particular reading here denotes the size, the length. So this is the length, and this is the dimension. This is the cross section view, so this is the dimension, right? So this here, this denotes the length of this particular pipe, and then here this denotes the size of this particular pipe. So, and also we have seen the legends. Now we may not able to move this beyond these prescribed lengths. Why we can't be able to move this? I'll show you guys. Because if we take a circle here, each sprinkler will cover a certain area. So this sprinkler will cover a certain area, and then this sprinkler will cover a certain area. I'll just remove this, right? And I'll just go and just extend it a little bit. This sprinkler will cover this much area, and then for the next sprinkler it may also cover this much area, and it may have an overlap with this sprinkler, and then this sprinkler also, this sprinkler system also may overlap with the other systems here, and like this we may have for this as well, like this. This overlaps with this, and this overlaps with each other. Then so all the sort of parts of this building may get covered. So I'll just make another one here like this, right? So if I move this particular sprinkler, let us say if I move this particular sprinkler now, if I move it 3 feet this way, right? Let's move it 3 feet this way. So moved it 3 feet that way, right, in the upwards direction, the north direction. So can you see this particular area is now devoid of any fire let us say the water that comes from the fire sprinkler systems. Can you see in this particular, and then if I move this sprinkler system here, let us say 2 by 2 feet here as well, can you see this area is now not being covered by the sprinkler systems at all. So if there is a fire here, the sprinkler system, the discharge from the sprinkler system we won't get the coverage from the sprinkler system here. So that this presents a major hazard in the fire safety system. So that is why we have to follow these plans and follow these design plans very accurately, and as much we can. And then if there is a clash in coordination, we may raise an RFI, that is the request for information, and then coordinate with the different clients and just solve those particular issues in a coordination meeting, right? So let us start with our Revit now. I'll just go back to my Revit, and I'll use the plumbing if we have a firefighting template, we may use that firefighting template. Otherwise what we can do is we can use the plumbing template and then create. I'll open this plumbing template, just turn off this fabrication parts for now, and then if I go to the systems tab now, can you see we have sprinkler systems here, we have sprinklers, and then if I go down here we have plumbing feature. Okay, so I'll just go here. You see we have a pipe here. So let us create a firefighting pipe. So there are three types of pipes here in this fire protection system. We have to create, first of all we have to create the we have to duplicate the type here and then create these pipes and change the specifications of those types. I'll show you guys how do we change the specifications and the routing preferences. Before starting that, I have to mention one important thing in our fire protection systems. So if I go to the text here, you guys have to remember this very accurately. So if I zoom in here, can you see all the pipes are less than 2 inches in the diameter here? Can you see 1 by 4, 1 by 4? All the laterals are less than 2 inches in diameter. Why is that? And for if we have the bigger diameter pipes here, can you see this is a bigger diameter pipe? It is a 4-inch pipe, right? And then we may have some other pipes. This is a 3. Let me check. This is a 4-inch pipe here. This is a 6-inch pipe here. Can you see? For these the dimensions for the diameter for the pipes with diameter greater than 2 inches, we always use a fitting here. Can you see this fitting differs from the fittings on these laterals? Why is that? Because when a firefighting pipe is greater than 2 inches, or it is 2 inches and greater than 2 inches, so greater or equal to 2 inches, we use a fitting here called the vitrolic fitting. So for 2 inch and greater than 2 inch we'll use vitrolic, right? VICTROLI and see vitrolic fittings here. And then for less than 2 inches, right, we use our screwed fittings, just like we used plumbing system, SCR. I'll just select SCR here. Can you see in these particular pipes we simply use our screw fittings, and then in the larger pipes greater 2 inches or greater we'll use our vitrolic fittings. So I'll just show you how to create those pipes in my standard plumbing template. So what I can do is I can go to the pipes here, I can edit type here, and I'll just duplicate this and then rename it as, you should rename it according to the the notes and the general things that we have to that a project has been given, that has been designed by the design engineer. So I'll just simply use for this project, I'll just use SP. So it's my main pipe. I'll just use caps lock SP. I'll give it a dash and I'll just use main. This for the main pipe. I'll click OK now. After changing the name, what we can do is go to this segment here called routing preferences. I'll select this routing preferences. I'll click this edit button here, and then can you see we have some routing preferences here. If I go here, can you see we have some of the families, but we always use carbon steel, and it should be schedule 40, but I don't have that particular family loaded here. So what I can do is I'll just take that family, download it from the internet, or this may be provided to you by the client himself. So I'll just change it to schedule 40 carbon steel, and then I'll just give the minimum size and the maximum size from here. And then similar thing I'll do from elbow. I'll always use, since it's a main pipe and this should be in inches, I'll just change the template to my sort of a imperial template, and then we'll get feet in inches. I'll just change this to I'll just take the minimum to 2 inches and the maximum to, let us say, 10 inches, and then I'll use carbon steel here, and then I'll just change all the fittings to vitrolic. I'll just load those families here. Vitrolic elbow, vitrolic tree here will just be vitrolic junction, and across all the families that we have to select here should be vitrolic. And in the similar thing, I'll just create another pipe here called SP. So just change here to SP branch or lateral, BRANCH, or you can just simply say it LATERAL, lateral here, and then let us give it a 1. I'll click OK, and then all these routing preference should be done. Since this is a less than 2 inches, I'll select less than 2 inches here, and all these fittings should be threaded fittings, right? For our pipe dimensions less than 2 inches, we always select threaded threaded sort of plumbing fittings, right? So I'll just do it, take the correct family, insert that correct family here, and set up all the pipes here, and then we'll take a look at the modeling, right? So now I've set up this template, and I've loaded all the families here. So what I can do is I can go to the system tabs, and now I can go to pipe here. If I go to the pipe here, can you see I've loaded all the all the families. I've created SP main, I've created branches, and I have some other sort of PVC pipes, etc., standard copper pipes, etc., etc., that has been loaded. I've actually not loaded this myself, my team has loaded this for me. And then can you see here, it is a carbon steel, the diameter is 8 inches, and then since the main pipe it is 8 inches, it is greater than 2 inches, and then the system type here is fire protection vect. We have to select the correct system type. I've shown you guys in the previous masterclass how do we create a different system type using the families here. We'll just simply search that, go here, search that, search the fire wet system type, and then copy paste it, and then create a new system here. I'll just extend, just close this one, and then we have some work sets here as well. Okay, so let me select that pipe, the SP main pipe. I'll show you guys the preferences I've done here. So I'll just go to the edit. Now can you see I have selected the carbon steel as well. I have different families that I've loaded here, but I've selected the carbon steel as well. And then for the fittings, I've selected all the Victoric fittings. Can you see we have Victoric fittings here as well. I'll just select the minimum size as 2 inches, and then we have some T, etc., etc. Flanges, since it is greater than 2 inches, it is not it is sort of not a threaded fitting for the main pipes. That is why we use a flange here. Otherwise there is no flange needed in threaded fittings. And then we have some European, all of them have been selected as Victoric. I'll select OK, and then OK here as well. Can you see we have some middle elevation, lower elevation, and the upper elevation, just like in our plumbing systems, and just like in our, we can select the diameter here. We have the range of diameters here. We have the middle elevations. We can give the stub up just like we give in HVAC or in plumbing. And then let us select the different type. We have a branch type here. If this is the branch type, in the branch type I'll just go to routing preferences. Now can you see the minimum size is, I'll just select the maximum size here. Can we see we have a carbon steady floating? You see we have the fittings here are threaded. We have threaded fittings here, and the flange is selected as none, since for threaded fittings we don't have a flange, and there's some sort of cap here as well. I'll click OK, and then OK. Now so guys, let's set up this project. So I've loaded the template, I've loaded all the families that I have, I've created different types, and I've loaded all the routing preferences according to the different families that I have. I've loaded all those families here. So where I can see those families, how I can get those families. So you can simply open a project which has that particular families, select those families, and then just copy and paste those families over here. Or you can simply go to the add those families using the library section, or simply go to the I'll just show you guys this, because I don't think I have shown you how to download all the families. So on Google, I'll search this BIM object page. You just search BIM object here. I'll just select this, and after selecting this I have to log in, and after I log in, I'll just log it in. I think I have that login here. BIM object, do we have some BIM object here? BIM object login. Yeah, no, I don't think I have. Yeah, I have that login here. So no, I have to log it in manually, so I'll just log it in. So I've logged in, guys. So you can directly search all the families from here. For example, if I want fire protection pipe, let us check if it has FPP, or let us search fire protection pipe, maybe. We have some colors. I don't think you'll be able to you have to, so I don't think you guys will be able to find those families here, but other families you can find. We have different sort of, you can just search on Google, guys, where I can get the families for fire protection system. You just get the you'll just get that family. So if I want, I want a car family, or let us say a window family. I think this will work for architecture only. I want a window family. I'll simply go to Windows. I'll simply search it. Can you see we have different sort of windows? How do I get those windows into my Revit? I'll simply download it here. We have different sort of files here. It will just select only the RVT file, that is the Revit file. We have a RFA family here, or RFA.RFA. I'll just download this in my downloads folder. Go in the downloads folder. It is not yet downloaded. I'll simply grab it and go to the Revit and then paste it on the Revit here directly. Can you see it is now upgrading it? And after it has been upgraded, you'll directly able to get those families here and place it in your floor plan or whatever else you want. So let me set up this project. In similar way, you can go to different websites and create get the hydraulic fittings, etc., right? So let me set up this project. So we have some grids here that has been provided in our template. Let me quickly just link a file here. I'll just go to the manage, where is my manage here, and go to my manage links, and I'll just add an architectural link here. I have my architectural link. I'll just go to desktop. I'll just go to, I think it's in my download folder. Yeah, here it is. I'll just open it, and now let's get a little bit time to open. After the link has been opened, I'll just click OK here, and I'll just expand this. Can you see my architectural file is now visible? I'll simply go and do some settings here. I'll just go VV, that is my visibility graphics. I'll just turn off some annotation categories, or they have been turned off here. So I'll simply go to Revit links. I'll just make it half tone, and underlay it as well. I'll just simply click OK, and then I can go to View tab here. I can go to the View tab here, and then I can save this particular template from this view, and then simply for each level I simply select those particular template from here. Can you see we have a no template selected here? I'll simply select that particular template that we have created. We'll be able to select that from here and apply it. Can you see? Okay, so what I can do now is, let us create a pipe, right? I'll show you guys how to create a pipe. I'll just go to the system tabs. I'll go to the pipe. I'll select the SP main here. I'll select the appropriate diameter and the middle elevation accordingly, and go back. Let's go back. Let's create it using this design drawing we have, guys. Okay, so guys, without wasting too much time, let's start modeling, guys. So we'll just do this this part later and the current part later, and now we'll simply move to the level 1. I'll just show you this level 1 because there's a lot going on in this particular level. Can you see we'll be starting with the main line here, and the main line is near the grid C. We have this main line. It is the dimension is 6 inches, and then the other line we have is in 4 inches. So how do I see at which elevation this line is and where it is oriented? So for that, I'll just remember this grid C, and then check, do we have some section here? Yes, exactly. We can see here we have a section here, 4F, this section we have here, and then this section line exactly goes through these two pipes that we're going to be modeling. So I'll just check this section, where the section is. I think it is on this page. Yeah, here we have that particular section. Can you see? In this section, before how do we read this particular section from this? So we'll just see the direction of the section. I'll just take an arrow here. I'll just take a pen here. Can you see on this particular section, we are viewing from this angle, from this arrow. We're standing here, and then we're standing here, and then we're viewing in this in this direction, and everything on the left, everything on this side should be on the left, on this side should be on the left, it should be on the left, and everything that we see on the downwards of this section should be on the right, guys? So everything on the left should be this, and everything on the right should be this. So I'll just check this. So if I move closer to C, we have a grid C reference here, and then I go here. Can you see closer to this grid C we have two pipes? One is the main pipe, and other is a 4-inch pipe. They are both the main pipes, right? I'll just try to see this. If I near to this grid C where we can locate these two pipes. So we will get a cross section of these pipes. We won't be able to see the length of these pipes or the top. We will just see the cross section of these pipes. So I'll just try to locate it. So here is my grid C, and then near to this grid C we should have on the left side, can you see guys, this is grid C, and if we going away from the grid C, we have to see on the left side. So grid C, and on the left side, can we see we have some cross sections of two pipes. So exactly these are the two pipes, this one and this one, that we are going to be modeling. So we have sort of just have a idea of where these two pipes lie and how this riser, we have seen this this sort of equipment in the ground floor plan. Can we see, if I go to my ground floor here, can you see we have this equipment here. So this pipe exactly goes up, and then if I go to the next page, I'm able to see that equipment here, and then this takes a left turn here, and then we have to model these particular two main pipes. Just model these particular two for now, right? But I'm not able to see the elevation, at which elevation these two pipes lie. So how do I check this elevation? I actually have the elevation for this pipe. Can you see? For this pipe and this pipe will have a same elevation. It will have an elevation of 11 feet 9 1/2 inches, right? So I'll just go and use this particular elevation. It is a 6-inch pipe. I'll just go to my Revit now. I'll just move close to, this is my I'll select the main pipe. I'll select diameter here as 6 inches, and then middle elevation I have to select according to this. It is 11 feet 9 1/2. Just go back to my Revit. I'll just give 11 feet 9 1/2 here, and then move to close to grid C, and then sort of place it according to grids. I'll just check the grids again. It is starts exactly from this room here, just north of grid C, right? I'll just go here in this room, just north of grid C. I'll just place it all the way to the end. Sorry about that. I'll just click on here and then extend it all the way to here. I'll escape it for now, and now I'll place this pipe, but I'm not able to see the orientation of this pipe. I'll simply take a section here, go here, and then take a section and see if this has been selected at the correct level. I'll just go here, I'll double click on it, so I'll just go to the view here. I'll just expand this view. Can you see my pipe lies here? So I'll just VV and turn off all the levels here. I'll click OK, and now let me select this pipe here and then see it in the section here. I'm able to select this pipe, see this pipe now. Can you see guys? This is my pipe, and it has now been placed, right? Why is it why it is green? Because I think in my families I've selected the graphic overrides here. Let us check. I'll just double click it. Is it green here? It is green. I'll just change it back to white. I'll click OK, or should I change it to black? Let me see if it works. Yeah, I have to change it black. Simply double click here, go to the graphics override. I have to change it to black. Okay, OK, and OK. Or should we change it to red, guys? In order to match the other ones, I'll just double click on it. I'll quickly do the red here. OK, 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 and OK here. So I'm able to see this now. So let me see the other pipe. Okay, I'll go to back to my level 1. I'll just go to PI. PI is the shortcut pipes. I'll just go to main here again, and the other one is 4 inches. I'll just moderate close to this, and the middle elevation, I think here I have to check upon that. I think it is 12. I'll just give 12 for now, and I'll go back to my here, and can you see it is close to this, right? So I'll just model it for now. Later we may be able to change this. Just place it up until this. Just place it until this for now. I'll just escape it, and now my two pipes have been selected. I'll just fill the section. Looks alright. Looks according to this this section here exactly. And then Now what I'm going to do is, if I go near to this level 1 here, I'll escape. Now I'll just CS, which is create similar, and I will try to create a branch here. My first branch is here, and it is a 4-inch pipe, and the length of this pipe is 6 feet 1.5 inches. So let us try to create this pipe. I'll show you guys how a hydraulic fitting looks, where it is near to the grid. It is grid 1 and 1.8 and 2, and the distance should also be mentioned here. Yeah, you can take the distance from this. I'll just model it freehand for now. It is 6/1/2 and it is 4 inches. Okay, go back here. I'll select 4 inches here between 2.3, and then I'll select this, and then I'll just model it 6/1/2 inches. So it is, I think, 6. I just created 6 feet 3 inches for now. Can you see, guys? A hydraulic fitting has been created here, and then we can model it according to this. We have a, I think we have a stub up here. Yeah, we have a stand pipe here, and in the similar manner, do we have some fitting here as well? I'll have to check out the other views for that, and then let us create some branches. Guys, if I want to see a little bit more about this, the branch that we took, where it goes, I can simply go to my my review here, and can you see we have a section here? It is 54 FP 302. I'll just look at this section. I think it's a stand pipe. I think, yeah, is this the section? I don't. This is on the right side, so this means it is not the section. Yeah, this is the section, right? I'll just take a split view. I'll make sure if this is the section. If I zoom into this, 54 FP 302, 54 FP 302, can you see we have to correlate between these two pages here, and the section number is 1. Can you see 1 here? And the section number should be 1 here, and this is exactly the section that we're looking for. And we have created this main pipe, and then we have created this 6 inch. This is 6 inches, and this is 4 inches here, and then it goes on the left, and then we have a stub up here. We have some other fittings here, and it goes up, and then we have some valve here, etc., etc. So we're not going to be modeling that. I'll close this for now, and let's model these sort of laterals here. And for these laterals, we have to take a dimension from somewhere in this design drawing. Can you see we'll get a dimension from the grid? Can you see from this particular grid, which is the 1.8 grid, the first sort of lateral is at a distance of 4 feet 9 inches. It is 4 feet 9 inches. So I'll just take the 1.8 and then start modeling from this 4 feet 9 inches distance away from that particular grid. I'll just go to the grid 1.8 here, and then is it 1.8 or yeah, it is 1.8, 4 feet 9 inches. So I'll just take a model line here, or detail line DL. I'll just create this model line here, and then I'll just DI, which is the dimensions from this particular grid, and I'll just select this line, and then change the dimension here. It is 4 feet 9 inches. I'll just go back to my Revit. I think it is 4-9 inches. I'll just, now this has been correctly aligned. I think it is exactly at grid 2. Let me check it again. Have I read it wrong? No, I haven't. So it is basically on grid 2, so I should have spotted it earlier. And now from this 4.2 as well, we have some dimensions here. Can you see this sort of lateral should be 4 feet 8.5 inches away from this 4.2 grid. So I'll just try to model this. Let's model this. Let's model this particular one, the one we gave the detail line to. So I'll just go back to my Revit now, and now let's go back to my design drawing here. Can you see we have two pipes here, from which pipe we have to take the branch connection. Can you see here we have the line goes over sort of this 6-inch pipe. This is 6-inch pipe and this is 4-inch pipe. So line goes over this pipe. This means that we have to take the connection from this main line. And also remember guys, these are welded connections, so we don't have to provide the connections here. Make sure that we'll just align these sort of sprinkler, the branch pipes up to this main pipes, because the connections provided here are not Victolic connections, they are not threaded connections, they have to be welded. So they are welded on this side. So I'll just do this. I'll just go here, I'll just select the branch pipe here. I'll just give it a correct, I think it is 1/4. Let me check. So I'll have to change it to SP branch first, and then 1/4 I think. Let me check it. It is 1/4. And then the first pipe is, I'll just model this pipe. It is 6 feet 11 inches. I'll just go here, just make sure if I am looking at the correct one. No, I'm not. So this one, it is 6 feet 11 inches and 1/4 in diameter. I'll simply go 1/4, and then middle elevation should be 12 feet, exactly like this. And then I'll just start modeling this. So I'll just have to do it again. PI is the short form from pipes, and then I'll just like branches here and just go 1/4 here, and then middle elevation should be 12 feet I think. And then I'll just take a branch from this pipe. I won't take the branch like this because it will give it a fitting, right? What is the middle elevation for this, guys? It is lower elevation is middle elevation is 12 feet, right? So I'll just select this, and now let me model it. PI branch is 1/4 12 inch. Can you see? I won't be selecting this because it will give a fitting to it. So I'll just simply start modeling from this particular point, and then I'll just extend this. I'll show you guys. I'll just extend this a little bit now, and I'll just align it AL. Just tab it here and then align it to here, right? You see guys, it has now been aligned, and now you guys can give it the dimension according to the drawing. Here we have 6 feet 11 inches. I think I have to do it like this. So let me just give a detail line here. I'll take the dimension DI from this tab. You have to do this only once, guys. I'll just select this pipe, and then 6 feet 11 inches, and then I'll just align this pipe up to this, and now it is okay. AL, align this. No, AL up to this, right? So I'll just delete this now and delete this line again, and now I have to place a sprinkler here. What type of sprinkler I have, I have to check. So this is a round circle, so this means that I have to select an ordinary upright sprinkler. So I'll just go back to my here, and I'll just go to Revit. I'll just go to systems. I'll check this sprinklers here. I'll select the sprinklers. Now all the sprinklers, the families that have been loaded are here. I'll check if I have some upright sprinkler. I do have some upright sprinklers. I'll just place it exactly here. This is a slanting sprinkler, inclined sprinkler. I'll just select, do I have some other sprinkler? Upright. So let me check if I have some upright sprinkler. I think this one should work. It is slanted. It isn't placing correctly. Let me check this one. So this one works. I'll simply place it here. I think it has not been placed correctly, so I'll just leave it for now. Can you see this is the coverage of this particular sprinkler that I have installed. This coverage should be according to the legends that I've given here. Can you see we have some specifications given here. All the sprinkler families should be loaded according to these specifications, and the spread the K factor that we have here, etc., right? The response, etc., the 160 degree, etc. So whatever you want according to this legend should be modeled and installed in our templates, right? So let me model some other things. I'll just extend this. I'll just take the dimensions later. I'll show you guys how these sprinklers actually work. Let's disconnect them for now, cancel it. There are some errors in this template, guys. Oh, it has taken a sort of a this here, right? So it takes a, so what I can do here is I'll just leave it here and then let's model it. I'll show you guys how it is modeled, guys. I'm not able to show you guys, so I'll just cancel. I think there's some problem with the families. Okay, so let's start modeling these the laterals that we have. We will go back to my design drawing here and we'll select this lateral here. Can we see, do we have a lateral? Yeah, from this 4.2 it is at a distance of 4 and 8.5 inches. So I'll just go back to my Revit. I'll select I think it's this one. It is this one. So I'll just take a detail line, or I can simply just draw it here. I go PI is the shortcut for pi. I'll select the branch here. I'll select the correct diameter. I think is 1/4. It is 1/4. The middle elevation should be 12 feet. It is 12 feet. So I'll just start drawing it. I think it is. I'll just take a look. It's 4.2. It is 4. Okay. So it is 4.2. I think it's here. I'll just start drawing it. Let's play this for now, and then if I zoom in, I'll just try to align it with this pipe. We don't give a connection here because this is a welded connection, as I've explained earlier. So I'll just align it with the center of this pipe, and then I'll just give a dimension di. I'll take a dimension from the center of this pipe, and then it is 10. It should be 1/2, right? So I'll just go back to my Revit now. I'll select this pipe now. Escape again. Select this pipe. Now I'll be able to change the dimension. It is 4 feet 6. Is it 6? I keep forgetting the dimension. It's 8 1/2, right? 4 feet 8.5 inches, right? So now it has been aligned correctly, and now let's place some sprinklers. So I'll go back to my the first one is a pendant sprinkler, and then I'll just then we have some upright sprinklers. I'll go back. I'll place the upright one first. I'll just go to the systems tab now. I'll just go to the sprinkler here. We have an upright sprinkler. I just select an upright sprinkler according to the according to the legends, according to the all these factors, etc. We have to select the exact sprinkler that we know. I'll just select this light pendant. Temperature should be 155 degree Fahrenheit here, and then according to this temperature I have to select this sprinkler. I'll just go back to my Revit now. I'll just place it arbitrarily first. Just place it arbitrarily here, and here. I'm pretty sure that this will be placed on the floor or somewhere else, so I'll just check the location later. I'll just place this pendant sprinkler first. I'll go to sprinkler again. I'll just select the pendant sprinkler. Do we have some pendant sprinkler? I think it is dry one, so I don't want a dry one. Pendant hosted. Let us check if this works. It doesn't work. Let me check the other one. No. Sprinkler pendant will be. Let's check this one. No. Do I have the correct family for that particular pendant sprinkler? Let's check the other ones. Try. Okay. Sealed. Let me check this one. No. Do we have some other pendant sprinkler, guys? Let me. Can you see? I'm not able to see this circle. This circle denotes the range, so I'll have to maybe this one. Doesn't work. So I'll just PEN. So one of them should work. I think this one will work. Yeah, this one will work. So I'll just paste it here arbitrarily. I'll just go to the section now. I'll place a section here. Control Z it. It is not straight. I'll just place it straight. I'll just go to the view now. Go to the view. Can you see? I'm not able to see the sprinklers. Why I'm not able to see the sprinklers? Because I'm pretty sure they have been placed at the floor. I'll just turn off the levels now. I have turned off the levels. Can you see I'm able to see the sprinklers here? So I'll just go sure I'll make the find here. Can you see? Now I'm able to see the sprinklers. This sprinkler is upright and this is a pendant. Can you see? If I select this, this is also an upright. I think the pendant will be placed here. Yeah, it has been placed here. So I'll just give certain let's place this upright one. I think my pipe is at the wrong elevation. Simply give it an elevation of, let us say, let's give an elevation of 10 feet for now, right? So I'm just modeling. I haven't let me sure what at what elevation this is. So it is at 11 feet 9 inches, and the pipe system here should be above that. So maybe there's an error here. I'll just give it middle elevation of 10 feet 6 inches for now in order to show you guys. So this is an upright one. I'll just select both of them by pressing the control. I'll simply move them from this base point up to here, and now control Z it. Let's do it again because I lost that sprinkler. I'll just make sure now I'll be able to control Z it. Let's move them one by one. Sometimes the general commands don't work, guys. It happens to the best of us, right? So I'll just select this and then move to here, and then we have some pendant sprinkler here. I'll just move it here. Just try to expand this, and then let us move this using the command. Now I think it is here. Now it is placed correctly. Now if I go back, I have some standards. I'm pretty sure that this may have some standards how to place my sprinklers. So here we have some standards for our upright sprinklers. So can you see we have some maximum spacing that has to be given from the underside of the slab, and then if we have a beam here, what should be the maximum spacing that has to be done. So this is actually the minimum spacing, guys. And then we have some here as well. We have to take the look at these tables here. Now let us give I think the maximum here is 22, the maximum here is 22 again, so the minimum should be 6 inches. So we'll just give we'll just be on the safe side. I will just give us a minimum of 6 inches everywhere side, right? So guys, this is steel section. This has to be maintained, so I'll just give a dimension of 6 inches here. Di, I'll just select the top of the floor, and then this should be 6 inches. Let's give that 6 inches to be remain on the safe side. I'll just give 6 inches here, 6 inches, and now it has been placed correctly. So how do I connect that sprinkler to the lateral? Now I'll simply select it. Can you see? I'll right click it, and can you see we have an option here called draw pipe. I'll just draw this pipe. We can change the diameter of this pipe. Let it be at 1 inches. I'll simply move it to the center line of this pipe, and now it has been selected. We'll do the similar thing with this. We'll just align it, AL, align it with align this top with this, like this, and then I'll simply escape it for now, escape it again. I'll just go and draw a pipe here and connect that pipe to here. And now similarly I can do that for pendant. I simply here right click and then draw the pipe and get the pipe right here, right? So now these are placed. If I go to the level 1, now they are placed correctly. Now one thing that we need to make sure is the spacing. I go here, and now let me place it according to these spacings here. We have 6 feet 10.5 inches. I'll just go here, I'll select this pendant, and I'll just give dimensions first from the, let's give the center line, and then this, and then center line to this, and then center line to this, and then control Z it here to here. Okay, done. And then let us move them. I'll select this sprinkler first, and then 6 feet 10.5. I'll just go here, 6 feet 10.5 inches here, and then I'll select the second sprinkler. I'll just check the dimensions again. It is 2 feet 9.5, 2 feet 9 inches plus 8 feet 10 inches. How much is that? So I'll go back here. I'll just select here 11 feet 7.5 inches according to my I've done the calculation in my mind, guys. Please recheck this. And then the last one is 11 feet 7.5 inches. I'll go here. Let's check the last one. 11 feet. I have to go here first. I'll just extend this pipe, tab it if you're not able to see this, like the pipe. Now I'll just take the pipe from here. Not able to select the pipe, guys. Tab it. Now I'm able to select it. I'll just extend it a little bit, and now let us move the sprinkler. Now it is 11 feet 7.5 inches. Okay, now it has been placed correctly. And then at the end, can you see where is this? At the end we have this sort of a little section here. So this section we have to cap, right? So I'll just try to select this, move it closer, and then right click on it, and can you see we have an open hand, or you can simply cap here as well, right? So the cap has been placed. If I select this, can you see we have a hydraulic. So do I have some other pipe caps? So let it be at hydraulic. So now we place these sprinkler systems. We also have a branch from this particular side as well. So it is, you see here, it is 4 feet 8.5 inches in length and 1/4. So I'll just simply go here and try to recreate it. So I'll simply CS it like this, and then align this, and then I'll simply, it is, how much is that? 4 8.5. Let me see if I can do it like this. So I'm not able to do this. Okay, let it be. I'll just simply cap it now. Cap, open it, and place a sprinkler. What type of sprinkler we have? We have a pendant sprinkler. I'll simply copy this, or simply create similar, CS, and then place it here. I'm not able to see this. I'll just copy this one, Control C, Control V it here, and then let me see what is at what the it is, should be at the end, right? So I'll just move it. I'll just delete this now. I'll just move it a little bit, and then just move it a little bit, and I'll just place this at the end, right? I'll just, if I want to check it, I'll simply move this and then go to the section and check it. Has to be here. So we have something in the way. I'll just simply go here and place it here, and then draw the pipe here, and then place it here, right? No, it has been placed correctly. So like this you can place all the sprinklers. I'll show you. I've already created this. You have to place some pendant sprinklers here. You have to give, in this particular drawing you have some other types of sprinklers. I think they are concealed sprinklers with a 160 degree Fahrenheit temperature of the bubble, the liquid inside the bubble, right? And then guys, I'll show you guys how I've modeled this, and then let's model. I think you guys can model this as well, because so guys, from this assignment I've already modeled some part. Let me show you what a part I've modeled. So I've modeled this sort of all the sprinklers. I've given some tags here as well. So I've given the appropriate distance between them. I've also labeled them. Here we have a butterfly valve. I've also applied the butterfly valve here, and then this part I've also modeled. There are some sprinklers here, different types of sprinklers, and also here can you see we have a different sort of color in the pipe. Why is that? Because here we can see we have a PVC pipe here. It is a rigid, it is schedule 40. So I've also used some threaded fittings here as well. So all of this I've done, and I've modeled these this riser here as well to the point of connection, and in this area I've also modeled some things. And then let me show you the other levels. So this is the dimension plan. I have modeled some plans as well. So let me show you guys the sheets. So this is the first sheet. Where is the sheet? I'm not able to see the sheet. So this is the dimension plan. I'm not able to see that plan. So this is the, let me expand it. Okay, so this is the let me change it, BV. Just click is first and then let's change it. So because I had to manage the lengths, I have to do all these settings again. And let us change this to half tone as well, and underlay. You see, now place some sprinklers here. I've placed all these hangers here as well. I hope you guys know how to place the hangers. You can simply I'll just show you how to place the hangers. You'll just go CM, that is the component, and then we have all the components that are loaded. We have the butterfly valve, we have some other types of valves, we have some can you see, we have some some hangers here as well. Let us search HAN. You see, we have hangers. We have 4-inch, 1-inch hanger, other hangers as well. So we'll just use this one. Let us say we'll just use 1-inch hanger for the 1-inch pipe. Do we have some 1-inch pipe? So I'll use this hanger here. I'll just use space. I'll just take a different hanger. I think this one will work. So I'll just drop it here, and then I can rotate it using this option. Rotate it 90 degree, and then if I click on this, we have some settings I can do here. We have levels, we have thickness, other things. So we can also do some editing in the edit type here as well. So this way we can place some hangers. I've already placed hangers in this portion here. Can you see, if I click on this hanger, it is a this type of hanger. So I'll just CS create similar, and then I can place this hanger here. Can you see? By similar way we can place all the hangers. So let me show you guys this plan, and then we have this plan. I'll just select this, and then VV, and then go to Revit links, and then underlay it, and then halftone it as well. I'll just OK it. Can you see, guys? I've placed different hangers. We have some pendant sprinklers. Do we have some upright sprinklers here? I don't think we have. These are the concealed sprinklers, guys. Why they are the concealed? Because they are aligned to the false ceiling. Can you see, we have ceiling plans here? If I go to ceiling plans, so I have to set this up. So what we can do is how to place these concealed hangers. I don't think I have shown you guys. So I'll just place this hanger just like any other hangers. I'm sorry, just like any other sprinklers. We have a concealed sprinkler here. So then what I can do is I can take a section and align that particular hanger to the ceiling using the section. So I think you guys can do this. It's very easy, guys. And then we have some schedules as well that I've created. I'm not able to show you the whole plan. I don't know why. Let me see if all these settings are yes. Okay, now I understand, but I'm not able to see this plan. Open. So I should be able, now I'm able to place. I'm still not able to show this sheet here, but that's okay. So I've placed some legends here as well, piping legends. I've placed the sprinkler type, and then I've given some work set to and filter to it as well. If I go to VV, can you see filters? So where are the filters? In this, maybe VV. If I go to VV, do I have some filters? Yeah, I have created 2 set of filters here. So similar way you can create all the filters. Let me show you guys with the 3D of this. So VV, I'll just go to Revit links. I'll just underlay it and I'll just tweak it. So can you see, guys? So, okay, so I have a crop view active here. Can you see? Now it will be visible. If I make it down. Can you see how I've modeled this one? Like this, I've modeled it all the way down. You see, I've given a point of connection here as well. Then I've modeled these particular pack. So what is left? I think you guys have to model these rack here. I think it is not too difficult to model. You can use this isometric view to model this. You have to take a sort of stub up here, use all the sections to get the middle elevations, lower elevations here, and then sort of, I think we have some separate plans for these stand-up pipes here as well. Here you can see the stand-up pipes. Here you can take this equipment here, and then I think the length of these pipes, and then so guys, I think this is it. Just try this assignment, and see you guys in electrical modeling.